Hello everyone, welcome to Chemazon-Complete Chemistry. In this video, we are going to see a very important difference between these three concepts of what is a quartet or a first order quartet, AB quartet and doublet of NMR spectroscopy. Okay, so this question has been asked in NET December 2024 chemistry paper that was recently published, and before that also in GATE also similar question is asked between concept of quartet and AB quartet. So let us first see what is quartet. When we get to see a quartet, quartet means we know that a signal will be split into four different peaks like this. Okay, and according to the Pascal's triangle, what is the ratio? 1:3:3:1. The intensity ratio. What is the meaning of intensity ratio? Suppose this is, let's say it is 1, then this will be 1, and height of this will be, comparatively it will be 3. Okay, so we know that. So for this CH2 proton adjacent there are 3 protons. So using n+1 rule, we will get 3 plus 1 is equal to 4. So for this CH2 proton, this will be split into a quartet. Okay, and in quartet, if you see 1:3:1. Okay, 1:3:3:1. So here there is only one J value. What is the meaning of J? That is the distance between the two splitted peaks. Okay, that is nothing but called as the coupling constant. This is the J value. Okay, coupling constant. So here it is same. Okay, there is only one J value, and at the mid of this, here which value is there? Here we have the delta value. Okay, delta or the chemical shift. Okay, so always remember a quartet, or we can call it as a first order quartet. Okay, it has one chemical shift value and one J value. Okay, this we know. So what is an AB quartet? So AB quartet, it is mostly seen in molecules where there are two isolated protons and they couple with each other. Okay, that is called as this. Okay, this is called as a second order coupling constant. So there is, suppose there is one carbon, and to this carbon there are two hydrogens, let's say A and B. Okay, and this A and HA and HB, they are non-equivalent. Okay, why they are non-equivalent? Because of the presence of a chiral center. Okay, we'll see the examples. The second point is this is found mostly in presence of protecting groups, like all these protecting groups where CH2 group is diastereotopic. Okay, now what is the meaning of diastereotopic? We had seen in the topicity video. Okay, suppose here there is Cl, CH3, then HA and HB. Now you replace, one time you replace HA with some group, let's say deuterium. Okay, and then with HB you replace it with some other group. So you will get two chiral compounds, and they both are what? Enantiomers. So this is called as, these protons are called as enantiotopic. Okay, here there is only one chiral center that will be generated. Okay, after you replace HA and HB, you will get enantiomers. So they are called as enantiotopic. Now suppose there is some chiral center that is already present. Suppose this one. Okay, and then here there are two hydrogens. Okay, and then here HA and HB, if I want to find out what will be the relation between these two, now already one chiral center is present. So if you replace HA or HB, you will get two different sets of diastereomers. So these are called as diastereotopic protons. So always remember, in case of diastereotopic protons like this, so HA will couple with HB and HB in turn will couple with HA. So what you will get is a AB quartet. Okay, so these are the examples. So in all these examples, the bold one you can see, this is AB quartet. So there will always be one chiral center that is present. So this is showing AB quartet. Here there is this chiral center. Okay, AB quartet. Here this is the chiral center. AB quartet. Then this is the chiral center. Here also same thing. This is the AB quartet and this is the chiral center. Now how does this AB quartet look like? Okay, so here also there are two splitted peaks. One is this doublet and then there is a longer distance, okay, like this. Okay, so here you can see this value, okay, this is J value and here there is one J value. So here if you see, this is J1 and this is also J1. Okay, so here there is one J value, that is one coupling constant value, but here you can see there are two different chemical shift values. Okay, so that is a basic difference between quartet and AB quartet. Quartet there is one chemical shift and one coupling constant, whereas in AB quartet there is one coupling constant but there are two chemical shift values. Okay, and finally what is a doublet of doublet? Now here there are these two hydrogens that are adjacent to HB, okay, HA and HB. Now suppose HA is equal to HB is equal to HC, okay, if all these three are equivalent then you get a triplet. Okay, but if they are not equivalent then what will happen? The J coupling between A and B, JAB, it is not same as that of J coupling between B and C. Okay, then what will happen? Okay, suppose I write this JAB by this yellow color. Okay, so what will happen? A will split the signal of B into two. Okay, that is a doublet. Okay, this is JAB. Now this, which one will split first, whether A or C, that depends on the value. Okay, if JAB is greater than JBC, okay, the coupling constant of AB is greater than BC, then A will split the signal of B and then C will couple. Okay, so first AB and then C, it is what? It is also only one proton. So both these single peaks will be again split into doublet like this. So the difference here is, here also you are getting 4 peak, but here the intensity ratio will be 1:1:1:1. Okay, whereas in AB quartet the intensity value, it depends on something called as change in the chemical shift, okay, by J value. Okay, the intensity depends on this value. Okay, okay, so here the intensity ratio is different. And how will the peaks look like? The peak will look like this. Okay, the distance between the two doublets is similar to that of the AB quartet, but the only difference is that the intensity ratio here, it is 1:1:1:1. Okay, so finally, to summarize, now we have to identify all these four, what are they? Okay, so here you can see standard 1:3:3:1. Okay, and the J value is also, all three are same. So one J value and one, this one will be the chemical shift value. So this is a quartet. Okay, now here if you see, here there is this J value and this J value. Okay, but there are two chemical shift values. So one J and two chemical shift values. This is what? This is a AB quartet. Now here just now we saw 1:1:1:1 ratio. Here also there is only one J value. Okay, intensity ratio is same. This is what? Doublet of doublet. Okay, you should know their short forms as well. Quartet is written as Q, or sometimes it is written as QT. Okay, mostly it is written as Q only. Okay, quartet is written as Q. AB quartet is written as AB and then small q. Doublet of doublet is written as small dd, like this. Okay, so coming on to the question that was asked. So there is this first one X, okay, Cl, CH2, CCl, Br. So in both these cases, methylene proton. Now you must know what is a methylene proton. Methylene means CH2. This group is called as methylene group. So this black one I have marked. This is the first molecule. Okay, you should know how to draw. First write Cl, then CH2, then CCl, okay, Cl, Br and CH3. Bracket means they are branched. Okay, or branch, or you can say substituents. Similarly, the second molecule will be like this. Okay, so the first one is X, second one this is Y. Now we have to identify the splitting pattern. So in X, how do you identify for a AB quartet? We had seen they should be diastereotopic. Now here in X, can you see any chiral carbon? Is this chiral? No, because two hydrogens are same. Is this chiral? The answer is yes. This is a chiral carbon. Methyl, bromo, chloro, and then this group. Okay, so here in A X they are what? They are diastereotopic protons. So HA will split B into a doublet. B will in turn split the signal of HA. So what we will get? Here we will get a AB quartet. Okay, and then the next one. Here if you see, is there any chiral center? No, here two groups are same. So this will, both are equivalent. So they will behave like normal. So here adjacent there are 3 protons. So 3 plus 1. So this will behave like a single order quartet. So the answer is AB quartet, and for Y it is quartet. So what is the correct answer? Correct answer is option 3. Okay, that's it for this video. I hope you have understood this very important concept of what is a quartet, what is AB quartet, and what is doublet of doublet. Thank you.